Alright, so here's question 11, and it talks about an interval PQ. So I've drawn an interval PQ over on the side here, and it tells me that the distance from P all the way to Q is length P, little p here. I also know that A lies somewhere on that interval. So you can see, if I have a look, that means PA plus AQ, the interval AQ, which is the same as QA. We can write QA, same thing. So let's do this. So this bit plus this bit, there we go, should equal P, right? So the total length of that is P. Now that's handy because we're trying to find PA. That's what we're trying to find. And if I look at what we've been given, so I've written what we've been given here, I'll make PA the subject, and I know that PQ, looking at our interval over here, PQ is length P, and I know that QA, I don't want QA, I want everything in terms of P's and PA's. So I'll just rearrange this. So QA is the same as P take away PA. So I'm going to sub that over here. It's the same as P take away PA. Expanding that out, we get a P squared minus a little p, PA, how's that work? If I put everything on the left-hand side, so I'll just rearrange that, I have my PA squared, I'm going to add the P lots of PAs, and I'm going to minus the P squared, that equals 0. So just putting everything on one side. If you think about it, it's a quadratic in PA. So if I swapped PA to x, it would be x squared plus px minus p squared equals 0. So when the question says find PA, if I was looking at this, it would be the same as find x. Find PA, it's like find x. So, but I'll do it over here anyway. So PA equals, so if you think about it, we're going to use, if you want to find x or solve for x, you're using the quadratic formula, because we've got lots of, we've got all these letters, so we want to do it in the, you have to use quadratic formula in this case. So negative b, so negative b is negative p, plus or minus the square root of b squared, so p squared, minus 4a, a is just 1, and c is negative p squared. That whole term, so this whole term here is the constant, all over 2a. And all right, so if I just have a look at, if I separate that, so remember, so we've got negative 4 times negative p squared, so that's positive 4p squared. I'll do it slowly. So we've got p squared plus 4p squared. Okay, and then let me just move this down a bit. All right, so remember we're solving for PA, which is like our x. So if we have a look at that now, we've got minus p on 2 plus minus, we've got 5p squared. So the square root of 5p squared is the square root of 5, and then we'll pull out p squared. We'll square root p squared, so we get p. So I've got square root 5p on 2. Now the trouble with this is, remember, we're looking at PA, an interval from P to A. So this has to be a positive. We're just looking at the distance, so we're not interested in direction. So distance is a positive. But if I have a look at what I've got, so I know that PA, I'll say but PA has to be greater than 0, right? It's got to be positive. So if I go back to what I've got, I can't use the negative and then the negative, because it's all be negative. So, I mean, I've got to stick with the first being negative. I can't change that. But now I'm only going to take the positive part of this part, because I need everything to be positive. So it's going to win, because the square root of 5 is bigger than the square root of 4, which is 2. So if it was square root of 4, it would be negative p plus 2p. So you'd get a positive p. So we're good there. We're now going to get a positive. So the question was find PA given what we know there in purple. So that's what we've done, I think. Oops, sorry. So PA equals negative p on 2 plus root 5 on 2 p's. All right, so in terms of p, or you could put it a p there. You could say it's root 5 minus 1 on 2, lots of p's. So you can also write it like that. Okay, hope that helps.